Hello everyone, welcome to Xcoding with Alvin. In this video, we're going to build a Stocks API service that uses Swift to interface with the Yahoo Finance REST API. We're going to build this library using Swift Package Manager. With this, we should be able to build an app similar to the native iOS Stocks app. In fact, we're going to build this app using SwiftUI and Swift Charts in the next video tutorial. We will implement three main endpoints for this API service. First, search sticker symbols. Second, fetch quote details. And finally, fetch chart prices with its timeline. If you encounter any issue when working on this project, please download the completed Swift package repository XCAStocksAPI service. I have provided the link at the description below. You can also add this as a dependency to your iOS project. The minimum requirement for this tutorial is to have Xcode 13 installed in your machine, because we are going to use Swift 5.6 async await API. So, without further ado, let's begin and start coding. Okay, let's begin by create a new Xcode project here and select multi-platform template and Swift package. Click next and name it as Stocks API. Check this create Git repository on my Mac, so you will be able to push this to GitHub repo later. Let me create it on my desktop folder. Okay, so this creates the Swift package project for us. And now select this package.swift file. And the first thing that we are going to do is to change this Swift tool versions to 5.6. So this will also be compatible for Xcode 13 that ships with the Swift 5.6 XDK. Okay. And now let's remove all the comments from this package.swift. Okay, also let's remove this dependencies parameter. We won't be having any third-party dependencies. And next is let's add this platform. So this accepts an array of supported platform. Okay, let's declare an array. So for the platform that we are going to support, let's begin from iOS. We're going to support iOS 13 for the minimum, and macOS. For macOS, we're going to support macOS starting from Monterey and Catalyst as well. Let's start from version 13. And tvOS. For tvOS, same with iOS 13. And finally watchOS. Let's start from version 8. Okay, so these are the platforms that we are going to support for this library. Okay, and let's continue on adding the executable target folder. This will help us later when we want to execute and debug the library. Okay, I'm missing the comma here. So let's try first to Command S to save this. Okay, there's no problem now. First, let's expand this sources folder from the project navigator. And let's create a new folder. And let's give it a name of Stocks API exec, like so. And here, expand this as well. And right click, create a new file, Swift file. And rename this to Stocks API exec.swift. Okay, so let me set this to full screen and let's make the font a bit bigger. The first thing that we're going to do is to declare a main keyword. This will be the entry point for this executable target, and let's declare a struct, give it a name of stocks API exec. Okay, and let's declare a static func, give it a name of main, and let's make this async. So this main method will be executed when we run this. Okay, for now let's just print hello world to the console. Next is we need to declare this executable target in the package.swift file. So in here, let's navigate to the products and then declare a new product executable and give it a name of stocks API exec. Make sure we are using the same name as this folder that we have created before. Okay, and for the targets, let's pass an array of a string stocks API exec. Okay, so we have this executable target as the product now for this project. And next is let's also go to these targets and declare executable target here and give it a name of stocks API exec. And we are going to also add the dependencies. For the dependencies, let's add the stocks API. So basically our stocks API exec executable target will depend on this stocks API library. Okay, make sure to add comma here. Okay, nice. So let's go back to the stocks API exec and make sure we can import stocks API. And here let's replace this hello world with initializing the stocks API instance. So if you take a look here, Xcode by default generate this code for us. It provides this stocks API struct as a public struct, and it provides this public text property. Okay, so let's try to initialize this inside the stocks API exec target. Stocks API initialize, and then we simply print the text. Okay, so after we have declared this executable target in the package.swift, the Xcode will automatically generate the scheme for this stocks API exec. Let's run this and let's show the console. It should print hello world. So if there's this prompt developer tools access, just enter your password. Okay, if you can see here, we have this hello world printed successfully. So it means we're able to import the stocks API library target to the executable target and then initialize the instance. Okay, so now we can implement the stocks API library. Let's begin by implementing the API to fetch quotes given symbols. We will be using this API to fetch the latest price data in the list and showing the horizontal carousel containing the quote data later when we build the SwiftUI app. Let me open Postman and show you what the URL and the response looks like. I will also share the Postman collection for you, so you can just import it and try invoking the endpoint by yourself. Okay, so this is the Postman. Let me create a new request in here. Let me copy the base URL for the Yahoo Finance API. So this is the base URL, query1.finance.yahoo.com. And for the endpoint for fetch quote, let me copy. It's going to be /v7/finance/quote. And for this endpoint, there's one mandatory URL param that we need to pass. It is symbols. And for the value, this should be a comma separated symbols of the ticker. For example, Apple, it is AAPL, Microsoft is MSFT, and Google is GOOG, Tesla is TSLA. Okay, let me click this send button. Okay, we got the JSON response printed here successfully at the bottom. So let's focus on the first element in the result array. This element represents a quote for a stock symbol. It has so much information inside it. We won't be using all of these fields, and we're only going to add the ones that we will be showing in the user interface later. But feel free if you want to add any other fields that you need. Now let me put this Postman window with the Xcode window side by side so we can create the model and map this JSON response properly. Okay, let me close this console and open the project navigator, and inside this StocksAPI folder, create a new folder. You can type command option N and give it a name of models. Inside this models folder, create a new file, Swift file, name it as quote.swift. Okay, let me close the project navigator, command 0, and let's begin by declaring a public struct quote and make it conform to codable, identifiable, as well as hashable. This identifiable and hashable protocol will help us later when we build the SwiftUI StocksAPI. Okay, and for the identifiable, it requires us to declare the ID property, and for this, let's make this all public as well, ID. For this, we will provide a default value, initialize the random UUID. The compiler will give the warning that the immutable property will not be decodable because it is declared with an initial value which cannot be overwritten. In this case, this is okay as we will use our own UUID for this ID and we won't get it from this JSON response. Okay, so for now, let's just ignore this warning. Now let's implement the properties for this quote by looking at the JSON. So let's begin from the first one is public let currency. The type is string optional. Okay, so this is the currency, and the value, for example, this is the currency USD, GBP, rupiah, or rupee. Okay, and for the next one is market state with a optional string as the type. So this will be used to determine whether the trading is currently closed or active. Okay, third one is public let full exchange name. Okay, full exchange name. So just make sure you type the correct key. Make sure you have no typo, otherwise it will fail to decode later. Okay, so for the full exchange name, the type is going to be optional string. This is the name of the exchange where the stock is being traded. For example, Nasdaq in New York. And next one is public let display name. It's also a string optional. So this is the display name of the stock. For example, Apple Inc., Microsoft Corporation. Next one is public let symbol, also optional string, and this is the symbol of the stock. For example, Apple, AAPL, Microsoft, MSFT, Tesla, TSLA, and so on. And next one is public lat regular market price. Okay, so the type is a double optional. This is the current price of the stock. So this is it. And next one is public lat regular market change, the type of double optional as well. So this is the difference between the current price and the previous close trading day. Next one is public lat regular market change percent. It's also an optional double, regular market change percent. So this is the percentage difference between the current price and the previous close trading day. Next one is public lat regular market change previous close, also an optional double. So this is the previous trading day closing price. Let's continue. Public lat post market price. So if I make a typo here, just make sure that you don't follow me, right? Just make sure the key is properly mapped one-to-one compared to this JSON, okay? But for the final project that I provided in the GitHub repository, I'll make sure that is correct for all these keys, okay? And the type for this is a optional double, okay? Post market price. So this is the price after the trading activities are closed for that day. And next one is post market price change double. So this is the difference between the trading day closing price and the price after it closed. Next one is public lat post market price, post market change, public lat regular market open, also a double optional, regular market open. So this is the price when the market opens at the beginning of the day. Next one is public lat regular market day high. Okay, so this is the highest price at the time of the trading day. Next one is regular market day low, double optional. So this is the lowest price at the time of the trading day. And continuing on, public lat regular market volume. It's also a double optional, regular market volume. So this is the number of shares traded for this stock. Okay. Next one is let me check. Public lat trailing PE, the type of double optional. So this is the company's earnings per share for the previous 12 months. Okay. And next one is market cap, double optional. Market cap refers to the total value of all a company's shares of stock. Okay. And next one is public lat 52-week low, double optional, 52-week low. So this is the lowest price of the stock in the previous 52 weeks. Continuing on, public lat 52 week high, double. So for the 52-week high, this is the highest price of the stock in the previous 52 weeks. Next one is public let average daily volume 3 month, double optional, and this is the daily average of the cumulative trading volume during the last 3 months. And okay, now we have two properties left. Public let trailing annual dividend yield, double optional. So this gives the dividend percentage paid over a period, typically 1 year. And this is the last one. Finally, public let EPS trailing 12 months. Okay, 12 months. Correct? EPS trailing 12 months. Okay. So this refers to a company's earnings per share as a rolling total over the previous 4 quarters. It is used to measure a company's profitability. Okay. So we have all of these properties, and so this already conforms to the decodable and encodable. Okay, and we won't apply any custom init decoder for this, so it's going to be like a one-to-one mapping compared to this JSON response. Okay, but I will also create a public initializer in here. Actually, Xcode should provide the suggestions to complete the. Not sure why it's not showing it now. Maybe I need to close Xcode and let me try to reopen this. Okay, usually this happens. Okay, here we have this second suggestions, init currency, with all of these parameters generated for us. We can just enter here and it will generate all of these initializers for us. Nice. And let's just make this public. Okay. Okay, looks good. Now let's make sure to try and build it. Okay, the build succeeded. Now let's implement the model for the quote API response. So looking at this Postman JSON response, we can see at the root we have the quote response key. It contains another JSON. The JSON has the result key with the value of an array. This is the array of the quote model. Next, if we scroll down, it has the error key. Currently, the value is null. We need to find out the structure of this error value to be able to decode this properly. So let's try to remove these symbols from the URL param and then send this again. Okay, here's the JSON response. But looking at the root key, this is quite different compared to the previous one. So here the root key is finance. The previous one is quote response. And here we also have the results. This will obviously be nil, and we have the error response. So it's a JSON containing 2 keys. Both of them have values of string, code, and description. Okay, so we will handle this custom JSON by implementing a custom init decoder later. We also provide the custom coding keys to handle both of this and the success case. Okay, this one. So for now, let's create the model for the error response here. Okay, so go back to the project navigator, and in the models folder create a new Swift file, and for this let's give it a name of error response. Okay, this will be pretty simple. We just declare a public struct, give it a name of error response, make it conform to codable. We only have two public properties, public let code with the type of string, and public let description with the type of string. Let's also create a initializer that accept the code and the description. Now as code again doesn't want to provide the suggestion for this initializer, but let's just create it ourselves because we only have two parameters. It should be very simple. So make this public and then assign the parameter to the associated properties, code and description. Okay, so that's it for the error response. Now we should be able to implement this JSON for the quote response API. Let's go back to the quote.swift file, and above the public struct quote, declare another public struct, give the name of quote response. Okay, and make it conform to codable. First, we're going to declare the public properties. We're going to have the public let data. This will be an array of the quote model, and it will be optional. Second one is public let error. This will be the error response. This is also optional. And as we are going to implement the custom init decoder for decoding the JSON, we need to declare a custom CodingKeys. So let's begin by declare a enum CodingKeys, make it conform to the coding key protocol. Here we have two keys, quote response and finance. Okay, remember that the root JSON have two possible cases. One is quote response and one is this finance. Okay, we need to handle both of them properly. And let me show you here. Let me send the symbols. Okay, close this. Okay, next we also need to handle this nested JSON here. Quote response, we have result and the error key. Okay, luckily for the finance, it has the same key, result and error. So declare another enum response keys that conform to coding key protocol, and let's declare the result key and error key. Okay, now we can start implement the init from decoder. Okay, this is going to be custom. First, let's declare the public. Also, did I miss something? Type quote response does not conform to the protocol encodable. Let's forget about that for now. Let's declare the let container inside the public init from decoder, and here let's invoke try decoder container key by. This will be the root key, so this will be the coding keys.self. Okay, this is the container. So there are two possible cases. So let's use if let. If let quote, the first one is quote response key, right? The JSON that provides this key as the root, quote response. So if let quote response container, and then we assign it with invoking try optional container nested container. Okay, in this case we need to pass response keys.self. Okay, and for the key it will be quote response. Okay, so let's handle this first. In the body, let's assign the data by invoking try quote response container, the code if present, and for the type it's going to be an array of quote model. Okay, and for the key it's going to be result. Okay, as you can see in here. And next one is error. We're also going to invoke try quote response container, the code if present, passing error response.self for key error. Okay, and the next else if let finance response container. So this will be the case when the root key is finance. So just like above, invoke try on the container, optional, nested container kit by response keys.self for key finance. Okay, let's scroll down a bit. Let me assign the data with invoking try finance response container, the code if present, array of quote as the type for key result, and self error try optional finance response container, the code if present, it's going to be error response.self for key error. Okay, we handle these two possible root keys cases, and in the else block you just assign the data to nil. This shouldn't happen, but we still need to assign the values to both of these parameters. Okay, otherwise the compiler will fail, will complain. Okay, let's try to build. Type quote response does not conform to the protocol encodable. Oh, I think because of the init from the decoder, right? But it should be using the default encodable, right? We can just change this to decodable, okay? Because we won't be needing to encode this. But for this quote, we will need to encode this later when we build the SwiftUI app. Okay, let's try to build again. Okay, now the build succeeded. Now we need to debug and test this quickly, whether this decoding works. So to do that, let's just go to the stocks API exec and then just hack it a bit for now. Okay, so here let me just declare a let with a assigning tuple. This will be the data, and the second one will be the response, but we'll just ignore it for debugging. Okay, in here just invoke try, just force it, and invoke await. We're going to just use URL session directly. I think this one. Okay, data from. Okay, for the URL in this, let me just copy this. Okay, and then force unwrap this. Okay, this is just for debugging to make sure the decoding works. Okay, some error here. Okay, now we got the data. Next, let's name it as quote response. Here, let's just invoke try, initialize JSON decoder, and invoke quote response.self is the type, passing the data. Okay, and finally, let's just print it in the console. Now let's make sure you select this stocks API exec as the scheme and then run this. Okay, let's see from the console. Looks like the decoding is successful. We got the response. Nice, looks good. Now let's try to remove the symbols from the URL param and try again for the error response decoding. Okay, we got the quote response model, data is nil, and we have the error. This is the error response struct. Looks nice. Code, bat request, description, missing required query parameter, equals symbols. Okay, so the model for this fetch quote is working as expected. So for the next task, let's implement the model for search tickers API. So here inside the Postman, let's create a new request and let me provide you the endpoint for search ticker. So here is the bash URL and the endpoint is going to be /v1/finance/search. Okay, and there is one mandatory query parameter that we need to pass, which is the query Q. Let's pass Tesla for the value and let me send this. Okay, so we got the JSON response. This time the JSON structure is flatter compared to the get quotes API previously. We only need to use this quotes key that contains an array. Let's name the element inside this array ticker instead of quote, as we already declared the quote model previously. Next, let's try out the error scenario. Let's try to remove this key from the URL param and send the request. Okay, so this is the JSON response. Okay, so similar to the get quote API, the root key is finance with the value of JSON containing the error response, as you can see here. Now we know how to handle the decoding properly for this API. Okay, now open the project navigator and inside this models folder create a new Swift file again. This time name it ticker.swift. Okay, so inside this file let's declare a public struct ticker, make it conform to codable and identifiable, hashable, as well as executable. Okay, then same with the quote, let's also declare a public let ID and assign it with a generative value of UUID. This won't be included in the decoding process from the JSON. Okay, this will be used for the SwiftUI later. Okay, so just ignore the warning. And next, let's declare several public properties for this. So the first one is the symbol, okay, with string as the type. This is the symbol of the ticker, if you can see here, whether it's Tesla, Microsoft, or anything. And second one is the quote type with the type of optional string. This is the type of the quote. The value can be equity, option, and others. We're going to only use equity for the SwiftUI app header. And next one is a short name. It's an optional string as well. This is the short name of the stock. And next one is long name. This is also an optional string, the long name of the stock. And next one is sector, optional string, the industry which the company belongs to, can be technology, etc. And next one is industry. Okay, industry is also, sorry, this is a typo, industry, also an optional string. So this is the industry which the company belongs to, consumer electronics, etc. And public let XCAStocksAPI. Okay, this is an optional string. So this is the stock exchange market where the stock is being traded, for example Nasdaq. Okay, these are all the properties. Let's also create the initializer. Let's also create the initializer for this ticker. that accepts all these parameters. Now again, Xcode doesn't want to provide the suggestion for this initializer, so again close this and reopen Xcode, and let's hope it will provide a completion. Okay, we got the suggestion that synthesize this initializer, and make sure to make this public. Now try to build this. Good, the build succeeded. Now let me close this project navigator and let's declare public struct, give it a name of search stickers response, and make it just conform to decodable. Okay, for this we're going to have a similar public properties. Public let's begin by data, and for the data we're going to have array of ticker. It's going to be optional, and for the error it's going to be error response optional, and we are going to also have a custom mapping, custom decoding for this. So let's declare the coding key. Okay, enum coding keys, make it conform to coding key, and the first one is quotes and second one is finance. So remember that the JSON structure for the success case and the error case is different. This is the success case, so here let's just provide the JSON at the root, expense, count, and quotes. We don't need the expense and count, we only need this quotes key. Okay, and for the error, the type is the key at the root is finance, so that's why we have these two keys as the root key. Okay, and let's continue for the nested JSON keys, and let's have finance keys. Okay, we have make it conform to coding key. For the finance key we have only one case, error. Okay, and let's declare the init from the decoder. For this, let's declare a let container. Let's get the container, the root container, decoder container hit by coding keys.self. Okay, now for the data we just invoke try optional container decode if present, and the type is array of ticker struct.self for key quotes. Okay, and for the error it will be always in the finance key, so let's invoke try container nested container hit by. For this, let's pass finance keys.self. Okay, and for the key it will be finance, and let's also change this directly by invoking the code if present. For the type, let's pass error response.self for the key error. Okay, so this is for the error and this is for the data. Okay, let's try to build it. Okay, nice, the build succeeded. Let's try this search stickers response using the same approach. Just navigate to the stocks API exec.swift, and let's just continue in here, declare another tuple. Let's just name it search data, ignore the response, invoke this. Let me just copy this, set the time to type them. Okay, for the URL, let's copy from Postman and replace this. Okay, continue on. We declare the let for search response, invoke try, Let's just try JSON decoder. The code is going to be search stickers response.self from the search data. Okay, make sure to pass search data instead of data. Okay, otherwise it will crash. And finally, we just print search response. Okay, so let me comment this. Okay, and for the moment of truth, let's run this. Nice, we got the search stickers response passing Tesla as the query. You see, we got the quotes array in here. Sorry, the ticker array here. The first one is this TSLA, and we also have the other one that probably match that this query. Okay. So if you see, this one is the Tesla that we know, Elon Musk Tesla. This is the industry's auto manufacturers, and well, this one is a consumer. I don't know what's this. Consumer cyclical. Okay, so different type of tickers. Okay, that's it for the search ticker API model. Let's continue to the next API model. It's going to be the model for the fetch chart API symbol. Basically, this model represents the series of timestamps associated with its prices given a date range interval. Can be like 1 day, 1 week, 1 month, 3 months, and so on. Okay, so we're going to use this model to display the line chart using Swift Charts framework when we build the SwiftUI app later. Okay, so here in the postman, let's create a new request and see the URL and the JSON response. So let me provide the URL. This is the best URL, and to get the chart for symbol, we need to use this v8/finance/chart. And for the last path, we need to pass the symbol, whether it's for example Tesla, we pass this TSLA. For Apple, we pass AAPL. Okay, so we only have the capability to get one chart per symbol. Okay, per API request, I mean. And for the parameters, there are 3 required parameters that we need to provide for this endpoint. So the first one is range. Okay, so this value is also predefined if you see here. So 1 day we need to pass 1 D, 1 week we need to pass 1 week, 1 month we need to pass this. Okay, I will show you the valid ranges later. It is provided in the JSON response. Okay, for now we just pass 1 day. And next one is the interval as the key. This is the interval between each of the timestamp in the array. For example, if we pass 1 day as the range, we can pass 1 minute for the better granularity in the timeline when we want to show the line chart later. And the next one is include timestamp. Let's just pass through in here to make sure the timestamps array are included in the response. Okay, this timestamps will be encoded using the Unix timestamp, so this is a number. Okay, and finally, also there's one other final key indicators, and just pass quote to make sure it's include all the quote details in the response as well. Okay, so these are the 4 keys that we need to pass for this chart API. Let's try this. Okay, send this. Okay, we have the JSON response in here. This one is a bit nested compared to the previous API responses. At the root level, we have the chart key with JSON as the value, and inside this JSON we have this result key containing an array as the value. Okay, this API endpoint only accepts one symbol, right? So the number of element inside this array will always be equal to 1. Okay, if the symbol exists, right? So if you pass a symbol that cannot be found, probably it will return an error, right? Okay, now let's analyze the single element in the array. So first we have the meta key containing the JSON with all the metadata for this particular symbol, right? It contains the keys for currency, symbol, time zone, GMT offset, trading period start date and end date for the day. So we'll be using this letter to display the chart for 1 day range when we build the SwiftUI app. So we need to decode this trading period. Okay, and as you can see, this is quite nested. So we also need to flatten and simplify this JSON letter. If you see here, it's the timestamp, and it provides you also the array of the indicator containing again a nested JSON quote, an array of open, high, close, low for that particular day. Okay, and each of those keys has the value of an array of prices. The size of the array here inside this timestamp will be the same compared to the size inside these indicators: open, high, low, and close, right? That will be equal. So this means that given the same index, we can get the open, high, close prices at a given timestamp. So we'll need to simplify this when we create the Swift model. We will have a single struct that provides the timestamp, open, high, and close price. Okay, now let's test the error scenario. Oh, before I forget, if you see that I mentioned before that here is the valid ranges that we can pass inside this. Okay, so 1D, I5D, 1 month, 3 month, 6 month, and 10-year, YTD, and max. Okay, and let's try the error case scenario. For the error less scenario, maybe we need to change this last path to a random character and then send this. Okay, it gives an error if you see in here. So okay, nice. The root key is chart, not finance, and you have the result, array, and the error. This is just like the previous JSON response, right? And okay, we'll handle this later when we create the Swift model. Now let me refer this random path to Apple, okay, so we can see the correct JSON response. And let's begin implement the model. Okay, first navigate to the models folder, the project navigator, and then just create a new Swift file again. This time give it a name of chart.swift. Okay, so given the information from here, let's begin by implementing the models for the indicator. Okay, let's declare a public struct and give it a name of indicator. Okay, indicator. Make it conform to decodable. Okay, I think codable is also okay. Codable. Okay. And we will have several properties here. Public let timestamp. We'll use date as the type in here. So this represents the time of the stock price. Next one is open with double as the type. This represents the opening price at a given time. And next one is high, double as well. So this represents the highest price at a given time. And next one is low. This represents the lowest price at a given time. And finally, public let close double as the type. So this represents the closing price at a given timestamp. For the SwiftUI app letter, we will be only showing the closing price inside the line chart. Okay, so let's also declare the public initializer. Okay, there's the suggestion. Nice, make it public. Okay, let's try to build, make sure there are no error. Okay, the build succeeded. Okay, now above the indicator, let's declare the meta struct, public struct. Let's give a name of chart meta. Make it conform to codable as well. Okay, we are going to implement some custom coding keys as well in here later. But let's declare the properties first. First of all is public let currency with the type of string. Second one symbol with the type of string. Third one is regular market price. This will be optional double. And next is previous close. This will be optional double. And next is GMT offset. This will be an integer. And next is regular trading period start date. We need to flatten this letter. Okay, they need decoder. Regular trading period end date. Okay. Now let's declare the custom coding keys. Make it conform to coding key protocol. Let's declare the everything here. Case currency, symbol, regular market price, previous close, and GMT offset. Okay, GMT offset. Remember, this is not camel case, so the O is a lower case. Okay, be careful. And next one, for handling that nested current trading period, we need to declare this case current trading period. Okay, now let's declare the JSON key for the current trading period. Declare enum current trading period keys and make it conform to the coding key protocol. We have 3 cases: regular, and finally post. Okay, and finally trading period is coding key. This is the final nested JSON. So we have the start and the end. Okay, now let's begin implementing the custom init from decoder. Let's get the container first. Try decoder container hit by CodingKeys.self. Okay, this will be very straightforward now. Try and container decode if present string.self for the key currency. Let's just provide the default value of empty string for the currency. For the symbol, invoke try container decode if present string.self for key symbol. Provide empty string as the fallback value. And regular market price. Okay, invoke. This one is try container decode if present. Let's pass double.self for key regular market price. Previous close. Try container decode if present, passing double.self for the key previous close. Okay, now for the GMT offset, we just invoke try container decode if present int.self passing GMT offset. Let's just provide a default fallback value of 0 in case it is null. and we need to decode that current trading period nested JSON, flatten it. So let's get the container first. Invoke try container, nested container, hit by current trading keys.solve for the key current trading period, and continuing on, let's only consider the regular and ignore the pre-post. Okay, so for the regular, let's get the regular trading period container, try current trading period container, nested container, hit by trading period keys.solve, and let's just use regular for the key. And finally, we can assign the property for regular trading period start date. Just invoke regular trading period container. Okay, this is an optional thing, and invoke decode passing date.solve for key start, and for the end date, regular trading period end date, invoke try and regular trading period container, decode that.solve for key and okay, I think that's it. Oh, this is an optional, right? Okay, let's provide a default value of just initializing the current date. Okay, and let's also just make this decode if present. Will this work? Okay, what about making this? Okay, I think that's enough. Okay, let's try to build this now. The build failed. The chart meta does not conform to the property encodable. Okay, so for the chart meta, let's just also make this decodable only. Okay, we don't need to encode this. Okay, that's it for the chart meta. Let's build again. The build succeeded. Now let's continue to implement the model for this element in this result array. So we're going to give it a name of public struct chart data and make it conform to decodable. Okay, this will be much simpler compared to this JSON. If you see here, we're going to only have the meta, chart meta, okay, and the indicators. Okay, this will be an array of indicator. If you see, the timestamp here is separated with the indicators. These indicators contain the nested key quote, and then inside it has the close array, the high array, the close array. Okay, we're going to merge this into the indicator and provide this as an array. Okay, so we'll need to do a custom strategy to handle that. Let's begin, and begin by implementing a custom coding keys enum conform to coding key protocol. For the first case, we have the meta key, and we have the timestamp key and the indicators. Okay, so the indicators itself provide a nested JSON, so we need to declare enum for indicators keys conform to the coding key and one key quote, as you can see, and inside the quote itself it has the JSON containing the close array, high array. I don't need to scroll this down because there are too many elements inside the array. Okay, but it will have the close, high, low, and open as the key. Okay, now coding key, we have close, high, low, open. Okay, so these are the custom coding keys that we will need to implement a custom init decoding. And let's begin by let's just implement this custom initializer that accept the parameter for now. Okay, make it public. And next, let's implement init from decoder. Okay, we will put all the custom decoder. We will put all the custom init decoder function in here. Let's begin by getting the container, invoke try decoder, container kit by CodingKeys.self. And next is the metadata. This should be simple. Meta equal to try container. The code for the type it should be chartMeta.self, and for the key it should be meta. Next is the timestamps. Okay, timestamps, we need to declare it let timestamps, and then invoke try container the code if present. Okay, remember that this is a Unix timestamp, and we are going to convert this to the Swift date. So we need to pass an array of that itself for the key timestamp. Okay, and let's provide a fallback value of empty array in case it is nil. Okay, next for the indicator, this is going to be a bit tricky, but we are going to use iflat to check the indicator container. Indicators container, invoking try optional, container nested container kit by should be indicators keys.self for key indicators. And next we need to get this array given the quote key, and to get this array, so the type of this will be any, right? Because we are going to apply a custom strategy to flatten this. So how can we get an array of type any? The strategy is declare a var quotes and invoke try indicators container and use this nested unkeyed container for key passing quote as the key. Okay, so these quotes will represent this array. Okay, so if you take a look of the type of these quotes, it's a unkeyed decoding container. Okay, and it provides you an iteration that you can just use to indicate whether it's already at the end. So whenever you invoke the nested container, it will move to the second element. Okay, so you can basically use like while quotes is at end, while it's not at end, you can just get the containers, invoke the nested container, right? But in this situation, we are already verified that for the chart API, the number of elements inside this quote will always be 1. Okay, so we don't need to use that while. We can simply get the first element in here, right? Let's just name it quote container, and this is just a let. Okay, so remember why we need to declare this as var, because the way that it works like an iterator, right? Okay, so it can be mutable whenever you invoke the decoding nested container, right? So in here, to get the first element, we just invoke nested container kit by, and we need to pass the code keys.self. Okay, and we need to also invoke try in here, try optional. Okay, and then in the else, in case one of these fails, okay, we just set the indicators array to an empty array. Okay, continuing on, we need to get the close, high, open, low array. So in the body, let's declare a let highs and invoke try quote container the code %. We need to pass an array of double, and I already checked that it's possible that the value inside this array is null. Okay, so we need to make sure to use this double optional, otherwise it will crash. Okay, let's solve. And for the key, it should be high, and let's do the same for the opens. For the key, open, lows for the key, low, and finally closes for the key, close. Okay, we got all the arrays beside this code. Nice. Now we need to map them to indicator. Okay, so we need the index actually, so we need to invoke timestamps enumerated. This will gives us the index as well as the timestamp element itself, right? So we need to map this to the indicator containing the timestamp, the high, open, low, and close price. Okay, and as you know that each array in here, this high, open, lows, closes, I already checked that the number of the element, right, the array count will always be the same compared to this timestamp array. So it is safe to use the subscript index to access the element, the array. Okay, let's just implement this so you will understand better. Okay, we're going to import use compact map as possible. One of the value is null, so when one of the value is null in here, I will just ignore it. Okay? I will not append it to the indicators included in the indicators array. Okay, so for the parameter, we have the offset and we have the timestamp. Okay, so we're going to use guard in here and get the opens. Okay, remember that this set to pass this offset, right? Because the number of the element will always be the same from the timestamp, and compared to timestamps, highs, opens, lows, and close. Okay, so we won't encounter like index array out of bounds. Okay, but remember that the value inside this element, right, at the particular index can be nil, so we need to use guard let. Okay, close, closes, offset, high, highs, offset, and low, lows, offset. Okay, and if one of them is nil, we just return nil. And finally, we can initialize the decoder, passing the timestamp, the open price, the high price, the low price, and the closing price. Okay, now let's build. Build failed. Okay, let's fix this. Okay, I see. Okay, let's make this simple, right? And just provide a empty array in here, so that's we don't need to use that question mark in there. Okay, this should be simpler now. Okay, and it should build succeeded. Okay, the build succeeded. We have implemented the chart data. It's quite complicated, but we have successfully flattened this and provides a much simpler data structure for the users to access to use our API. Okay, now we need to implement this root key chart. Okay, so at the top, let's declare the public struct chart response. Make this conform to decodable, and we have the data, the type of chart data array optional, and public let error response. This is also optional, And next is we're going to have a custom coding keys as well. So declare the enum coding keys. Okay, conform to the coding key protocol. We have one key chart, and so next we have the chart keys. So inside the chart there can be two keys, result and error. Okay, now let's just synthesize this public for this init parameters. But remember, we need to implement the custom decoder. Get the container, invoke try decoder, container keyed by CodingKeys.self, and we need to use flat chart container here in case that chart key does not exist, and invoke try. Oh, sorry, this should be coding key. Okay, conforms to coding key. Okay, try optional container and invoke nested container keyed by ChartKeys.self or key chart, and then in the else block we just assign the data as nil and the error as nil. Okay, and here inside this if let block, invoke try optional chart container decode if present, passing chart data array.self as a type to decode for the key result, and error invoke try optional chart container decode if present error response.self for key error. Okay, let's build this. Nice, the build succeeded. Now let's just test this, debug and test this. Go to the stocks API exec. Okay, and like always we're going to hard code it. Now let me copy this and paste this, and for now let me comment this, change this to chart data, and let me copy this, the URL from Postman for chart API endpoint. Okay, change this to chart response, and for the type it should be chart response.self from chart data. Finally, print chart response. Now let's build and run to see. Nice, it works. API is fetched, we have the response, and it is decoded to the Swift model successfully. Okay, we have the array of indicators, and then inside the indicator we have the timestamp, and at the given timestamp we have the open price, the low price, and the high price. Okay, this looks good compared to this JSON, right? Okay, we have all the meta information as well. Next, before we move on, let's also verify testing the error scenario. Pass a custom, just a garbage string for the ticker, and let's see. Okay, for the error scenario, they properly decode the error response here. Not found, no data found, symbol might be delisted. Okay, let's refer back to the AAPL symbol for the path. Okay, so we have implemented all the models that are required to implement the API service. Now let's build a single service to fetch all of these API endpoints. Okay, let's begin by navigating to the stocks API.swift. So this is the public strat that got generated when we create the project at the beginning of this video. And now let's import foundation first at the top. Okay, and let's remove this text property and declare a private let session and initialize URL session.shared singleton instance from the system. And the second one is JSON decoder. Let's initialize this using a lazy closure. Let decoder initialize JSON decoder dot date decoding strategy. So if you remember that the timestamps format from the Yahoo Finance API is using this number, so this is the Unix timestamp. So it means this is the second after the beginning of 1st January 1970. Okay, so we use these seconds since 1970. Okay, and finally let's return the decoder. Next is the dash URL for the Yahoo Finance API. So this one, https query1.finance.yahoo.com. okay, the test, I think there's one usage of this text, so for now let's remove this. In this video I won't implement test cases, but it's up to you if you want to implement it. Okay, and now let's replace this. Let's make this one-liner for the public init. Initialize this. Okay, now let's begin. Before we implement the public methods for our API service, let's declare an enum to represent the API error. Okay, let's declare it inside the models folder. Create a new Swift file and give it a name of APIError.swift. Okay. Oh, sorry. Go back. And here, let's declare the public enum API error. Let it conform to custom NS error. Let's declare several cases. First one is invalid URL and invalid response type. And the third one is HTTP status code failed. And let's provide two associated field status code with the type of integer and error, and let's assign error response. This will be optional. So for the HTTP status code failed, there will be two possible cases here. For XX server error, the server received the HTTP request but returned the error for XX. In this case, the server will return the JSON inside the HTTP body response. So in this case, the error response will be decoded. Okay, and the second scenario is for 5XX. This is usually happen when the server is unreachable. Okay, in this case, the error response will be nil because the HTTP body won't have the JSON. Okay, let's continue to implement the required properties for custom NS error. First one is static var error domain. Okay, for this, let's return StocksAPI for the domain string. Next one is the error code. Let's just use switch on self. For invalid URL, let's just return 0. For invalid response type, return 1. And for the HTTP status code failed, we don't need the associated values. Okay, in this case, just return 2. And the third required implementation is this error user info dictionary. So here we will provide the error text specific to each cases. Okay, let's declare text string. and we will return a dictionary and as localized description key with this text. Okay, now we have to fill this text using switch on self. So in case of invalid URL, let's just assign it with invalid URL, and for invalid response type, just assign it with the invalid response type. And then finally we have the HTTP status code field. Here we need to grab the status code, message value, and error response. Okay, so here I'm going to use if flag. If error exists in here, I'm going to assign error with error and then print the status code using string interpolation here, status code, and then provide the message error dot description. Okay, and in the else, when the error is nil, just going to print the status code. Okay, let's build. Okay, the build succeeded. We have implemented the API error for the Stocks API service. So let's navigate back to the stocks API.swift. Okay, now before we implement all the public methods for the endpoints, let's declare several private helper methods that will help us later when we want to fetch the data from multiple methods. Okay, so the first one is a private func validate HTTP response code. Okay, so this accept one parameter URL response, and this is also a throwing function that returns the integer. This integer will be the status code. First, let's assign use guard glad HTTP response, and let's cast this URL response to HTTP URL response. Okay, in case it fails, we just throw API error invalid response type. I think we can minimize this window and focus on this. We won't be needing that postman window anymore. Okay, continuing on, let's use guard. So we're going to use check if the HTTP response status code is within this range 200 to 299, and to check this using in range assertion, we can use this tilde equal. Okay, HTTP response status code. So if the HTTP response status code is within this range 200 to 299, then we're going to continue. Okay, and not and but or. Okay, or it is within this range 400 to 499. Okay, HTTP response status code. So for 2xx and 4xx, we're going to continue. Okay, because we need to decode the JSON in that case, in these two scenarios. Okay, this one for the result array and this one for the error response. So in this case, we're going to continue. Else for 5xx, we're just going to throw API error HTTP status code failed, passing the HTTP response status code, and for the error it will be nil because the HTTP response body won't provide the JSON. Okay, continuing on, we just return the HTTP response status code. Okay, that's the first one. The second one is private func fetch. So this accepts a placeholder generic that conforms to decodable, and there will be one parameter URL that we are going to ask the URL session to fetch, and make this an async throwing function. And the return type here, it will be a tuple. The first value is the decodable instance, and the second one is an integer. This represents the HTTP response status code. Okay. Next, declare a let, and this is going to be tuple, data, and response. Invoke try await session data from passing the URL. Okay, and continuing on, just declare the status code, and here we need to validate the HTTP response code by invoking try validate HTTP response code, passing the response. Okay, and I think we don't need to use code in here, so I think just response is better. And finally, we need to return the tuple. The first one, we need to invoke try await and JSON decoder. We're going to use our own JSON decoder instance and invoke decode. The type will be the d_order.self from the data. Okay, and the next one, the second value will be the status code. Okay, let's try to build. Sorry, this JSON decoder is not a async await method, so let's remove the await. Okay, the build succeeded. We have implemented the private helper methods. Now we can implement the first public method. Just declare a public func fetch quotes. The parameter is symbols. The type of string. Make this an async throwing method that return a quote array. Okay. So first we need to construct the URL, inserting the query parameter for that symbol, and we need to make sure that is properly encoded using the URL encoded standard. To do that, we can utilize the URL components query items array, and let me show you on how to do it. First, let's use guard var, give it a name of URL components, initialize URL components with this string, and let's use string interpolation for the base URL, and be very careful here when adding the path. So for the fetch quote, it's going to be v7 finance and slash quote. Okay, v7 slash finance slash quote. Okay, if this failed to got initialized, we're going to, if the initialization is nil, we're going just to throw an APIError invalid URL. Next, you can use this query items, URL components with query items. So this is an array of URL query item instance, and by using this, we will encode the value properly. For example, if you have white space in your string, it will add the URL encoded %20 to that space. Okay, so for the name, it's going to be symbols, and for the value, let's pass that symbols from the parameter. Next, we need to get the URL from this. We can, let's just guard let URL components.url. So this is an optional, so in case it is nil, we just throw APIError invalid URL. Okay, now let's continue by declaring the tuple, response, and status code. And for this, we need to use an explicit type. We want to decode quote response, okay, from the JSON body. And next one is integer for the status code. We simply need to invoke try await fetch passing the URL. Okay, now we have that response. So in case it is 4xx, then the error will exist in the response, right? So we use if let error response.error. In case the error exists, we're just going to throw APIError HTTP status code failed, passing the status code and the error response instance. And finally, if we succeed, we just return the response.data. This is the code array, and this is optional, so let's provide a fallback value of empty in case it cannot find the symbols. Let's try to build. Okay, the build succeeded. Let's try to test this quickly. Go to the stocks API exec and remove all of this head. And let's declare a static let stocks API, initialize the stocks API instance, and in the main body just declare a do try catch. In the catch just print error dot localize description. Okay, so let's declare quotes, let quotes, and then invoke try await stocks API fetch quotes, passing the symbols. Let's fetch AAPL, MSFT, GOOG, and TSLA. Okay, now print the quotes, and for the moment of truth, run it. Nice, working as expected. Good. Now let me try to pass an empty string to the symbol. Nice, the error response is properly decoded here. Error status code 400, missing required query parameter symbols. Amazing, right? Let's go back and implement the second one, search stickers symbols. For the second public method, let's declare a public search stickers, and for the parameter, query with the type of string. And for this, let's also add additional parameter is equity type only. Okay, and make it the type as Boolean with the default value of true. So basically there will be a different type that can be returned for the symbols, but we will add this parameter, so this will help us later when we want to build the stock SwiftUI app, because we only want to show charts for equity later. Okay, so make this an async throwing, and the return type is array of ticker instance. Okay, and in here first we're going to use the same mechanism to insert the query items. So I think I can just copy this, and I need to change this string, the URL string in here. So for this I will be passing v1. Okay, let's remove it first to make it safe. /v1, and then continuing on finance/search. So /v1/finance/search. And for the URL component query items, we will be having several query items. Let's replace these symbols first with Q, and here just pass the query. We'll add two more query items for this. Okay, next one is quotes count. This will limit the number of quotes returned in the array, so I'm just going to pass 20, limited to 20 maximum. And the last one is init. Here is the language. Okay, I'm just going to set it to en -us. Okay, so just the return an English based ticker. Okay, we have all the query items, we have the URL in here. Now let's continue by declaring the tuple let response and status code, And for the type of this, it will be search tickers response and integer for the status code. Just simply invoke try wait fetch, passing the URL, and here just like above, if response dot error, assign it to a flat error. If this error response exists in the response, then we just going to throw API error HTTP status code failed, passing the status code and the error. Next, we need to check if is equity type only is true, and in the else, for else, if it is false, we just return response.data, providing fallback value of empty array. If not, we're going to filter this. So response.data, okay, and I'm going to invoke filter in here. So basically we need to get the float type in here. So this is optional. Let's provide a default value and then invoke localized case insensitive case insensitive compare, and we're going to pass this equity string, okay, and we're going to assert it if it is same. So this means if this quote type property equal to the equity string in here, it doesn't consider the case, so it can be lower or uppercase. So if it is same equity, then it will be included in the return array. Okay, so let's try to build. Okay, the build succeeded. Now let's start debugging this by navigating to StocksAPI exec. Okay, let tickers try await StocksAPI search tickers. For the query, let's pass Tesla. Okay, and let's print the tickers, and let's comment this. And for the moment of truth, okay, we got these results, search results. It's an array of ticker. Is here. The first one is TSLA, Tesla, and also the other ones in here, tsla.mx. Okay, and that's it. We have implemented the tickers. Let's move on to the final API, the fetch chart API given a symbol. So for the fetch chart data method, it requires a date range interval for the timeline. So it can be, the valid ranges can be like 1 day, 5 day, 1 month, and so on, right? So if you look at this, let me show you the JSON. So it returns this valid range that we can pass in here for this range URL param. So these are the valid range. So for this, let's create an enum to represent this, and then we should be able to pass that enum inside the parameter for our public method. Okay, let's implement that. And inside the models folder, create a new Swift file, give it a name of ChartRange, declare a public enum ChartRange, make it the raw value type is string, and let's also make it conform to the CASTiterable. Okay, so for sure we cannot use this, right, for the name. So this is not allowed by Swift. We can use this, but I think it's a bit not very clear using this underscore. So let's just use this 1 day, okay, to represent 1 day, and provide the raw value of 1D, and 1 week. Remember, if you've seen the valid range array in here, there is no 1W here, so it will be 5 day. So if you think, right, in 1 week there are only like 5 trading days, right? So Saturday and Sunday there will be no trading activities in the stock market, right? So for 1 week, it's going to be only 5 days. Okay, that's the raw value for 1 week. Next is 1 month. For 1 month is 1 MO. Okay, be careful with the capitalization. They must be lower cases. And then we don't have 2 months, we have only 3 months, 3 MO. And 6 months, 6 MO. And YTD, it's yearly, I think. YTD, so YTD is YTD, so we don't need to assign the value manually, so because this is the same value. And 1 year, 1 year is 1Y. Second one is 2 year, 2Y. And after 2 year we have 5 year, 5Y here, and 10 year. Okay, so 10Y. And finally we have max. I think this will be the maximum lifetime of the stocks, so the value is also same, so we don't need to provide the raw value. Okay, and next, if you look at here, we have the interval, right? The granularity between each of these array, right? So for example, for 1 day we wanted the interval between this timestamp for the next one, and the next one is like 1 minute, right? So it can be represented clearly in the line chart later, right? So we also need to define the interval, make it public var interval, make this a computed property. Okay, and here we just switch on the self. So for 1 day, we want the use the interval of 1 minute for each timestamp, and for 1 week we want the, I think let's use 5 minutes. Okay, 5M. And for 1 month I think we can use 90 minutes as the interval. And this is case 1 month, and let's use 3 months. Let's use the same for 3 months, 6 months, YTD, and 1 year, 2 year. So for this, let's use the interval of 1 day for each timestamp. And for 5 year, 10 year, let's return 1 week, okay, between each timestamp. And for max, we're just going to return the 3 MO. Okay, I think this looks good. Okay, the build succeeded. Now we have the chart range. We can move on to implement the fetch chart data API inside the stocks API service. So declare public func fetch chart data, and for the parameter we have symbol, the type of string, and range, which is the chart range enum that we have just created. And make this an async throwing function that return an optional chart data in case it doesn't exist. Okay, here we just need to use guard. Instead, I'm going just to copy this again. Maybe we can do a little bit of abstraction if we want, but for now I think this is enough. Okay, and for this, let's change this to, for the finance, for the chart, I think it's going to be v8/finance, and /chart. And remember, for this we need to put the symbol at the last path of the URL. Okay, so this will be the symbol. Okay, actually we haven't, so I think this will also handle the encoding later when we convert it to URL. Okay, so looks good. And for the query items, first we have range. For the range, let's just pass range.raw value. Okay, and next we have the interval. For the interval, we can also use the computed property range.interval. And third one is indicators. In this case, we can just hardcode this quote string. And the last one is include timestamps. So let's just also pass through in here. Okay, so we have the URL components and we have the URL. Okay, let's declare the let. This will be a tuple response status code. And for the type will be a chart response integer in here for the second value. And let's invoke try await fetch passing the URL. And just like always, check if the error response exists. If let error response.error, in that case we need to throw API error HTTP status code failed, passing the status code and the error response. Continuing on, we can just return response.data.first. Okay, let's try to build first. Okay, the build succeeded. Now let's try this. Navigate to the StocksAPI exec and declare this let chart try if let chart. Okay, remember that is an optional. Try await stocks API fetch chart data. For the symbol, let's pass APL and let's pass 1 day for the range. Okay, so let's print the chart in case it is not nil. Let's run for the moment of truth. Nice, we got all the data printed nicely in the console. So this is the 1 day chart for Apple stocks. Nice, we should be able to build the line chart using Swift Charts framework in the next tutorial with all of this API. Okay, so we have all of these 3 APIs now, and that's it. I think those 3 APIs is enough for building the stocks API app later. And the next step, if you want to publish this, just create a new GitHub repository and then commit this change to your local Git repo, and add that GitHub repository, that public GitHub repository as the origin, and then just push it. Okay, I'm going to show you the completed Swift package repository that I have created. Okay, so here, let me show you how to add it to the iOS project. So this is my project, XCAStocksAPI. Okay, so this is our using the same APIs that we have created in this tutorial. Okay, it has the same interface. In addition, it has also ability to get the raw data, but I don't think we need to worry about that. If you want to check, you can check the implementation inside the sources. Okay, so to add this as a dependency to an iOS app, so let me try to create a new iOS project right in here. Select iOS, select app, let's give it a name of stocks app. Make sure we don't need to worry about this. Okay, just uncheck include test, and let me set my organization identifier com.alvinlosari. Just put in desktop. Okay, so this is the iOS project. So to add a SPM dependency, we just need to click this file from the menu bar, add packages, or you can also go here, stocks app, select this project, and select this package dependencies, and then click this plus button. So what you need to do is just to go to your repository, or this is the stocks API, and copy this URL, okay, this repository containing the SPM project, and basically you just need to paste it in this search bar, okay, and it will try to fetch the metadata for this stocks API for that SPM. So here I have provided the README, it is also rendered as well, okay, nice, right? It's also showing the image that I put in here, okay, and then you can just click add package. It will fetch data and then resolve the dependencies. And here we don't need this executable, we only need the library, right? Okay, so that's it. It's going to add this as a dependencies to this app. So basically in your app you can import like the XCAStocksAPI, okay, that's the name of my library, and maybe can add this as a property, initialize this XCAStocksAPI, and then basically that's it. You can just use it, right, in your code, in your project. So for example, here I'm going to get the quotes, just use the try await stocks API, fetch quotes, passing APL, and print error, apply step solution. Okay, that's it. How to add the dependencies to your iOS project. This is also not required only for using SwiftUI is not mandatory. You can also use this for SwiftUI, for UIKit. And if you remember, right, in these packages we support multiple platforms: iOS, macOS, Mac Catalyst, tvOS, and watchOS. So if you build targeting this platform, you can also use this package. Okay, so that's it for this part of implementing the stocks API service. Congratulations, you have successfully completed this, and I think you also learn a lot of things on how to decode this nested JSON, right, and how to flatten them. Because if you try to use the JSON the way it is, you need to declare a lot of nested model, a lot of struct to handle this. Okay, so that's it for this video. Thank you for watching this video. Like this video if you like it, unlike it if you don't like it, and please subscribe if you want to support me going forward. So until the next video, the building SwiftUI Stocks app, keep on being a lifelong learner, and goodbye.